Algebra 2, 6.5, Synthetic Division Algorithm. Now, there were 9 videos before this one for Chapter 6, and if you haven't seen them, you might become lost or confused, and you can just click on this description to watch those first. An algorithm is a systematic procedure. It's a set of rules to follow for doing a certain computation. And the division algorithm from the previous video, 6.4b, the video right before this one, can be shortened if the divisor is a linear polynomial. It's a polynomial without exponents larger than 1, like x minus 2. If we have a linear polynomial, such as x plus 2, we can rewrite it as x minus a negative 2 to put it in the proper form. Synthetic division uses addition instead of subtraction and avoids repeating numbers. And we can divide a polynomial by a binomial in which the variables aren't written. So we're not going to have any variables. Isn't that great? So here's our first one. We need to divide 4x to the third power plus x plus 7 by x minus 2. We can rearrange our work so duplicate writing is avoided, and we can divide using only the coefficients. So this one on the left is from video 6.4b. It was the long division method we did, and we had to take this first term and figure out what it needed to be multiplied to equal 4x to the third power of this first term, which was 4x squared. We wrote it here, and then we multiplied this second term by it and got a negative 8x squared. We subtracted and got 8x squared. We dropped down the x, and we did it again. We said x times what is 8x squared, and it was 8x. We multiplied these two and got 8x squared. We multiplied the 8x to the second term and got negative 16x. We did our subtraction, and we got a 17x. We dropped down the 7. See what we're doing here? It's just like the last video. So this is the long division method, and we ended up with a 41 as a remainder. Well, if we did this only using coefficients, so notice that in this one, there was no 4x to the second power. So we put a 0 here as a placeholder. We learned that in the last video also. So we need placeholders if there's a missing exponent, okay? Because it has to go it has to go x squared, then x to the first power, and then the constant. So that's why that 0 is there. So if you haven't watched this video, you really need to watch it. Otherwise, this one's going to become very confusing. So what we're going to do is we're going to keep that placeholder, that 0, but we're going to pull out all the variables. So now we've got a 4, a 0, a 1, because that's our buddy the invisible 1, isn't it? And a 7. And we're going to write them here. And what we do is we just slowly say 1 times what is 4? 4. We put it there. 4 times a negative 2 is a negative 8. We do our subtraction and get 8. And we bring down the 1. That makes a 0 pair. And 1 minus a negative 16 is adding the opposite. So we get a positive 17. We drop down the 7. And 1 goes into 17 times. We multiply them and get our 17 and multiply the 17 by the negative 2, and we get a negative 34. We have a 41 as a remainder. Now we can shorten this division process more by using the additive inverse for negative 2 in the divisor, x minus 2. So if you notice, we had this 1 minus 2. Well, if we had x minus 2, what we could do is use the additive inverse of this minus 2, this negative 2, and use a positive 2. And we would write our 4017, just like we had here, 4017, and we would draw a line, and the first thing we would do is drop down this 4. We write the 2 of the x minus 2 and the coefficients of the dividend. See, the 4017, and here's our divisor, see? Now, we bring down this 4, that first coefficient, and then what we do is you can follow in my colors here. In the red, we multiply this green 4 by that 2 to get an 8. That brings us here. We add it to that 0, and we get 8. So now we get a 4 down below the line and an 8. Now we're going to move to the blue. We're going to multiply this red 8 by the 2 to get a 16. We're going to add it to that 1 to get a 17. Now we're going to multiply this 2 by the 17 to get a 34, add them together to get the 41, and now this is our quotient, and that's our remainder. See? So we can write it like this. This is our quotient, and that's our remainder. See? We got a 4, an 8, a 17, and a 41. A 4, an 8, a 17, and a 41. What happens is that's our constant, that's our first degree, and that's our second degree. So we can write this starting back here. We got a remainder of 41. We got a constant of 17. It's a positive 17, so there's going to be a plus sign. Our first degree is just going to be an x, so we have 8x. It's positive, so there's going to be a plus. And then that's our second degree, so we have 4x squared. So remember, for this to work, the divisor must be in the form x minus a, or x minus 1, or x minus 2, or whatever. But it's got to be in the first degree with no exponent here. Okay, and there's got to be a minus. And if it's a plus, we can rewrite it as a negative of a negative, like we did over here, x minus negative 2, okay? So let's see what happens here. So we need to divide this polynomial by this binomial. So the first thing we're going to do is bring down this 1, see? And we're going to do 2 times that 1 is going to give us that 2. We're going to add these together and get the 8. Then we're going to multiply 2 times 8, and that's going to get us the 16. We add them together, and we get a 15 because of that negative 1. Now we multiply 2 times the 15 and get 30. We add it to the negative 30 and get 0. So we end up with a 1, an 8, a 15, and a 0. Here's our constant. Here's our first degree. Here's our second degree. We've got a remainder of 0. So we start with the constant. We got a 15. It's positive, so there's a plus. That's our first degree, so that's just an x. It's positive, so there's a plus. And that's our second degree, so that's our x squared. See? Because we don't write the 1, do we? Let's try it again. Here we've got this polynomial divided by that binomial. And if you notice, we have x to the third, x to the second, but there's no x to the first. So we're going to put a 0 in between here. And if you notice, that's a plus. So we're going to use x minus a negative 3. So there's going to be a negative 3 in this little box. All right? So you can follow me along here, or you can follow my pen. We've got a 2, a 7, a 0 for that missing space, and a negative 5. So it's really important that you notice there's a negative 5 there, because that's got to go there, see? So now we're going to do a negative 3, because that's a positive 3. We're going to do a negative 3, see? And we're going to multiply it by this 2 that we dropped down, and we're going to get a negative 6. And we're going to add these together and get a 1. Now we're going to multiply this negative 3 to the 1 to get a negative 3. Add it to the 0 and get a negative 3. Now we're going to multiply the negative 3 to the negative 3 and get a positive 9, and add it to the negative 5 and get a 4. And that's our remainder, that's our constant, that's our first degree, and that's our second degree. See? So we would have 2x squared plus x minus 3, remainder 4. All right, let's try it one last time. If you can see, we have x to the 5th power minus x to the 3rd. So we're missing x to the 4th. We're missing x to the 2nd. Okay, and notice that there's a minus sign here and a minus sign here. So we're going to have some negatives, and we're going to put in the zeros where the missing terms are. So now we're going to have 8, 0, negative 6, 0, 1, because there's a 1 there, isn't there? And a negative 8. So that's what we've got. And you can follow me along here, or you can follow me along as I point. It's up to you. So, because this is divided by x plus 2, see how it's written over the fraction bar? We're going to rewrite this as a x minus a negative 2. So we have a negative 2 in here. And we've got our 8, our 0, our negative 6, our 0, our 1, and our negative 8. And we're going to do negative 2 times 8 and come down. And that's going to give us a negative 16. We're going to add it to the 0 and get negative 16. We're going to do negative 2 times negative 16 and get a positive 32. We're going to add it to the negative 6 and get a 26. We're going to do negative 2 times 26, and we're going to get a negative 52. Add it to the 0 and get a negative 52. We're going to get negative 2 times negative 52. 2 negatives make a positive, so we have a positive 104. Add it to the 1, we get 105. Negative 2 times 105 is a negative 210. We add it to the negative 8 and get negative 218. Now, that's our remainder. So we got remainder negative 218. That's our constant. So we have a plus 105 because it's positive. This is our first degree. So that's going to be our x. That's going to be our x squared, x to the third, x to the fourth. So we've got negative 52x. So it's a minus sign there because it's a negative. Here's our second degree. We've got a positive 26x squared. Here's our third degree, negative 16x to the third. And then we've got our fourth degree, which is 8x to the fourth. See? Isn't that cool how we did that with no variables? It's a little quicker than doing that long division way, isn't it? All right, so all the previous videos from Chapter 6 are going to be in this video's description, so you can just click on them. And there's going to be some helpful videos from Algebra 1, where we did a lot of this. Not this in particular, but the stuff leading up to it. I'm going to add this video to the Algebra 2 playlist, and our next video is going to be 6.6. We're going to solve rational equations, okay? So, hopefully I explained this well enough. I always worry about that. Did I explain it well enough? Because I don't have anyone here saying I don't get it. So, if this was helpful and you liked this video, don't forget to hit the like button. Don't forget I'm on patreon.com, and Bitsy and Lola and I would really appreciate your help because I make these videos for free. I'll see you next video. Bye.